Okay, so we've now seen how to create simple expressions. We can take objects that are numbers like integers or floats. We can combine them together with operators, so we can say 3 plus 4 or 3 plus 4 all in parentheses times 5. That gives us a way of doing some simple computations, but it's pretty boring. It basically says we got a calculator. So we could type in expressions and get out values, but we'd like to obviously do more complicated kinds of things. One thing we need in order to make that happen is what we call a means of abstraction. Well, we can certainly write arbitrary expressions. It would be valuable, having written it down and gotten the value of an expression, to be able to remember it, to save it away by giving it a name, and then using the name to get the value back whenever we needed it. Fortunately, we have that ability. It's called assignment, and in Python, the format of that is shown here. We type in word, or a sequence of characters, followed by an equal sign, followed by some expression, whose value will then be associated with that word. So if I go over to my Python shell, I can do things like, I'm going to say, give the name pi 3.14159. And notice when it prints it out, it doesn't print anything out. It simply has done that assignment. That is basically, as we're going to see later on, created a binding of the name pi to that value. If I want to see the value of pi, I can simply ask the Python interpreter to give it to me, and it prints it back out. So I could do another binding. I could say I've got a radius of 11.2. Again, notice that it doesn't print anything out. If I want to get the value of radius, I can ask for it. But I can also now do things like create expressions. So I'm going to assign the name area to, and I can now write an expression as I would have before with now not just numbers, but names whose values are also numbers. So the area is pi r squared, where r is my radius. And I can say, okay, what is the value of area? And it did that computation. So I have an assignment statement. And notice here I'm using a single equal sign, which is why we use the double equal sign for comparison. A word or a name, an equal sign, and an expression says, get the value of that expression and bind to it, or bind it to, if you like, the value of the name associated on the left-hand side of that expression. Okay, so let's look at that in a little more detail. We say that we're binding a variable or a name to a value. And what does that mean? That statement, pi equals 3.14159, literally assigns the name pi to the value of the expression to the right-hand side of the equals. And you can think of this as literally creating a binding between a name and a value stored somewhere in the computer. So over here are all the values that are stored away in the computer, and I have somewhere within the computer a listing of all the names whose bindings I have done. As we just saw, we can retrieve the value associated with the name by simply invoking that name, just asking for what is the value of pi or pi. Now, I can change the bindings. So having bound a variable name, I can do another assignment statement. So for example, if I go back over to my Python shell, I could change the value of radius. Remember, initially we had radius of 11.2. Let's change it to something different. Let's change it to, in fact, I'm going to make this 14.3. So how do I do that? I say let's have radius be 14.3. Now what's my value of radius? There it is. Okay, what that has done in my diagram over here is it's changed the binding for radius. Remember before it was 11.2, it has now changed it to something else. But notice that area hasn't changed. And in fact, I can confirm that the area is still 3.94 point a whole bunch of stuff. And that's because my evaluation of the binding for area, having been done earlier, has simply stored away that value, as you can see right here. It doesn't have an expression to evaluate, it is the particular value. So rebinding radius does not change the binding associated with area. An easy place to make a bug or have a mistake, and something that you want to keep an eye out on as you move forward in terms of using these ideas.